Hello everybody, this is Nilima and I'm going to teach you the topic refraction of light. First of all, what is light? Light is nothing but a form of energy which is helping you and me to see. Not us, but everything around us we are able to see only because of light. But light has some certain criteria, some certain functions, some certain things which we call as either reflection, refraction, diffraction, and many other like these. But in today's topic, I am going to teach you is refraction of light. Just to tell you what is refraction of light, I have an example over here. Can you see this pen and this tumbler with some water in it? Is this pen a straight pen? Of course it is, not a question. Now let me just put this pen inside this tumbler. Now, could you see the pen a little bit tilted under the surface of water? I could see so. But why? Because of this term which I call as refraction. So what is refraction of light? Refraction of light is actually the bending of light. Since the light got a little bent when it moves from one material medium to another. When light moves from one material medium to another. Since in this example, we were seeing the light which was going from an eye to water, or we could say the light which was coming from water to our eyes. First it was in water, then it came to air, and then to our eye. So there was a change in material medium. That's why the term which is used to explain this is called as refraction. Okay, so I hope you must have understood what is refraction of light. Just moving a little bit further. Okay, so how do I measure that water will bend light this much, or another thing will bend light this much, like glass, how much glass will bend? For this, I need a certain criteria, I need a certain definition, I need a certain constant. So that constant is, I call as mu or n, which I call as refractive index. Refractive index of that material. Refractive index, which is equal to speed of light in air upon speed of light in vacuum. But where did speed of light came from? This speed of light is coming from, because this is the basic reason behind the bending of light. Why? Because when the light was moving in air, then it was moving with the speed c. So light is coming, it is moving with speed c. But later on, when it went into water, so after moving it into water, its speed changed. So because of the change in speed of light, I have this thing which is called as refractive index, which is a measure of how much the light will bend, which implies how much the refraction will occur. So refractive index, which is equal to C by V, okay, and this is actually a constant for a material. For example, for air, it is approximately equal to 1, and for let me say glass, it is 1.33. Okay, so one more thing, let me just quickly tell you, just a diagram for this. There was air here, and let here be water. Now the light I have incident on air, so when this light got incident, I will make a normal over this point. So after making this normal, the light will bend towards normal. Here is a bending, this implies here is refraction. So the bending of light, which is refraction, but when the light moved from air to water, the light bent a little bit towards normal. What is normal? Normal is a perpendicular that I have drawn on the point of incident. Okay, so will the light always be bent inwards to normal? No. So there is a basic criteria that we need to know. Whenever the light will move from rarer to denser medium, the light will move towards normal. And when the light will move from denser to rarer medium, the light will move away from normal. How? Let me just quickly draw a diagram. In this case, when I'll be having a rarer or denser medium, there is an incident light, here is the normal, light will move towards normal. But in the other case, here is an incident light, let here be denser medium, here be rarer medium, then light will move away from normal. Okay, but what is a rarer medium and denser medium? How would I know? I will know with the help of mu. For example, mu of air is 1 and let's suppose mu of another material is 1.33. Okay, so when 1.33 is greater than 1, this implies the other material is denser and the earlier one is rarer. Okay, one more just a little thing that I should mark. This is called an incident ray. The ray which got bent is called as the refracted ray. The angle which is made in between the incident and the normal is called as angle of incidence, and the angle that is made between the refracted and the normal is called as angle of refraction. Okay, so there are just two laws of refraction I would like to quickly cover just in a minute. The first law which says angle of incidence, the normal drawn and I'll say the incident ray, the normal and the refracted ray all lie in the same plane. All these things I've drawn on the plane of the board now. So that's why all of these are in the same plane. So this is the first law. Second law says the sine of angle of incidence upon the sine of angle of refraction is a constant which I've already told is mu. So this is also betterly known as Snell's law. So I've told you two laws. The first one, the incident ray, the normal and the refracted all lie in the same plane. The next one, the sine of angle of I to the sine of angle of R is a constant which I also call as Snell's law. So I hope with this thing you know the basic phenomena of light, which is refraction of light. All the best from my side. Thank you.